So this next project is done by machine learning students, but wearing a systems hat and developing an attempt to replace Spark. Okay, so we do have a new lab that encompasses this project and many other projects. It's called RISE Lab, and I forget the acronym exactly, but real time is in there, and maybe that's, I forget what the ISE stands for. Maybe someone can help me. Anyway, it's so new I don't even know what it stands for. But it's about real-time environments and about live data, not batch data. So really everything to date, when you start to look at the system side of machine learning, has been very much focused on batch data in one way or another, and analytics that take indefinite amounts of time. There are lots and lots of applications, including all the AI ones, but many others where there is a time budget of some kind, including medical applications where someone might live or die unless you act quickly, as you just heard about. And certainly the kind of self-driving cars and human-in-the-loop situations are involve time budgets. So let's look at these tasks and try to break them apart and think about what are their ingredients and think about system support that will allow you to make real-time actions and decision-making in a loop with still the big data context. So you need flexibility. You need to be able to put together not just things like neural nets, but planning and search and simulation. If you looked at the next wave of activity after applications to computer vision and speech, and even in speech, there was things around the neural nets. There's all kinds of other pieces to these big machine learning systems. This creates all kinds of complex task dependencies. It's not very easy simply to write a map-reduced kind of paradigm. You can write it, but it's not going to execute very, very effectively when you have very heterogeneous workloads and tasks. It needs to be adapted to the performance of the algorithm. As the system is learning, it's going to change its flow, its tasks. And then on the performance side, we have really the real-time and feedback kind of integration that I was talking about, which is critical in many real-world applications. So there are systems that target various pieces of this. What we're trying to do is build a system that targets sort of all these things. So very rough cartoon just to start you out. On the left, we have Hadoop, which is no longer the name of the conference. But Spark could have been. But these are very much block synchronous paradigms. So there was a map step, and then there was a wait step where everything's synchronized. And that was effective for certain kind of tasks where you as the designer could design it such that each task took about the same amount of time and needed about the same amount of resources. That's just not true for many, many emerging machine learning and AI paradigms. You need something much more like a just-in-time data flow type architecture where a task goes when all the tasks it depends on are ready to have finished. So building a system that supports that and retains all the desirable features of Hadoop and Spark is the goal of our project called Ray.